Hello, this is Mr. Stansbury. I'm going to take you through the 7C assignment. Okay, we start with number 1. The graph alongside indicates the distance run by a sprinter in a number of seconds. First thing we want to do is find the gradient of the line. So that's just the slope. So we want to find two nice points. Let's see, we could even just do this point right here, and 0, 0 is always a nice point. So let's go with 0, 0. And x first, so that's 24, and 200 is the y. We could have also used 48, and 400 would have worked just fine too. So to find the slope, we're just going to do 200 minus 0 over 24 minus 0. So that's 200 over 24, and then let's figure out what that calculates out to be. 200 divided by 24 gives us 8.3. Okay, so that's 8.3, and again the y was on the top, the x is on the bottom, so that's 8.3 meters per second, right? So for part B, interpret the gradient found in A, and that really kind of helps out to put our units on there. So that's 8.3 meters per second is how fast the sprinter is running. Okay, so that's B. Part C is the speed of your runner constant or variable. So since it's a straight line, that means that this has to be constant, because if it was variable, that means it would be changing and have some kind of curve to it of some sort, but running at a constant speed. Okay? All right. Let's take a look at the next one. That is number 2. Graph alongside indicates the distances traveled by a lorry driver. I'm not sure what a lorry driver is, but anyway, determine the average speed for the whole trip. So if we're looking for the average speed of the whole trip, basically you want to take the total time that it took, the total distance that it took divided by the total time that it took. So we start at 0, 0, right? So for A, we're starting at 0, 0, and we're ending at 11 and 9, 20. So we just want to find the slope of that line. Okay, so again we got 0, 0, and we got 11, 9, 20. Again, we're just going to divide, we're just going to subtract 0 from both of the y and the x, so it's really just, let's just take a little shortcut here. We got 920 over 11. So if we put that in there, 920 divided by 11 gives us 83.6 we'll go with. And that is, again, kilometers per hour. Kilometers per hour. Okay, so that's part A. Part B, the average speed from point O to A. And again, if you look on here, there's no actual O. That O stands for the origin. So this is truly O right here. Okay, so the average speed from O to A is just going to be, again, we've got 0, 0 here. Let's see, B, I here. We've got 0, 0 here, and then 2, 180. So again, if we take our shortcut, we do 180 divided by 2, and that gives us 90 kilometers an hour. Right? B, part II, from B to C. Now we actually have two. We don't actually have the advantage of starting at the origin with the 0, 0, so we actually got to put these two. We've got to use these 2 points to find the slope. We've got 5 and 420, and 7 and 640. So 640 minus 420 all over 7 minus 5. So let's see, that's going to give us what, 220, right? So just double checking. Yep, over 2. So you divide that out, and that's 110 kilometers per hour. And again, if we really want to make sure that this makes sense, we'll notice that Again, the whole trip is this slope of this line right here from O to A. It's a little bit steeper, so that's why the number's a little bit higher. If you'll notice, B to C is our steepest slope there. That's why that's our biggest number there. Okay. Part C, the time interval over which the average speed is greatest. So that's going to be the part that's got the steepest slope, and we just talked about that on BII, and that's definitely going to be this section right here. So that time interval, again, we're just looking for the time, which is the x. So part C is going to be from 5 to 7 hours is going to be the time interval where the average speed is the greatest. Okay? All right, next problem, number 3. Graph alongside indicates the wages paid to sales assistants. What does the intercept on the vertical axis mean? So that's this here. So that's really 0.80 right here. So what does that mean here? So this is X is the hours worked, and the Y is the wage. So this is basically saying they get $80 just basically for showing up for work. So that's their salary. That's what you get no matter how much time you work. So you start off with that. Okay. Part B, find the slope of the line. What does this slope mean? So again, since this is a straight line, we can use any 2 points. So to make our life a little bit easier, I'm just going to use 0.80 and 140. You can use any 2 of these points on here that you want. I just elected to use these 2. So 140 minus 80 over 4 minus 0. Let's see, so 140 over 80 minus 80 is 60. 4 minus 0 is 4, so that gives us 15. Okay, so find the gradient line. What does this gradient mean? This is 15, and again, it's always the wages, well, the Y first, so that's $15 per hour. So that's what they're making for every hour that they work, 15 bucks. Okay, determine the wages for working 6 hours. So a couple ways you can do this. Well, let's see, 6 is not on here. So really, and then 18, if you look, 18 is going to be way out here. So we're not going to really be able to use our graph too much. We're really going to want to, our best bet is going to be use to actually find the equation of the line here. So I'm going to do that. So part C, we've got, the equation of the line, we've got y equals mx plus b, right? We know that the slope, we just figured out that the slope is 15, so it's 15x. And then b is the y-intercept, and that is our 80. So there's our equation, right? So now we can just start plugging these in. So C part I, we're going to plug in 6 for this x right here. So it's going to be y equals 15 times 6 plus 80. Okay, so 15 times 6 is going to give us 90. Right, yep, plus 80. So that's going to give us 170. And since that's y, that's $170. So that means that if they work 6 hours, they're going to earn 170 bucks. Okay, C part II is y equals 15 times 18 plus 80. That's going to be a little tougher to do in our heads, so let's try this. Turn that on. We got 15 times 18 plus 80. And that's going to give us 350 bucks. So if they work for 18 hours, they're going to earn 350 bucks. Okay? If no payment was made for not working, but the same payment was made for 8 hours work, what would be the new rate of pay? So they're saying that you're not going to start here at 0.80. They're saying we're going to start here at, let's change the color here to make this a little easier. So that we're going to start here at 0.0, but it says the same payment was made for 8 hours of work. So now here's our 2 points. So now here's our new line here. Pretend that's straight and it goes through that point. What would be the new rate of pay? So then that's going to be, well, again, we've got 0.0 here, right? So we would do 200 minus 0, which is going to be 200 over 8 minus 0. So that's 200 over 8, right? So that is going to be, 10/4? Let's just get this on here. So 200 divided by 8 is going to give us 25. Okay, so now they're making $25 per hour. Okay? All right. Moving right along. Let's take a look at number 4 here. Graphs alongside indicate the fuel consumption and distance traveled at speeds of 60 kilometers per hour, graph A, and 90 kilometers per hour, graph B. Okay? Find the gradient or slope of each line. So we've got this here. They both start at 0.0, which makes it really nice for us. So the slope of A is going to simply be the y divided by the x, right? So it's 300 over 25, right? So we do 300 divided by 25, we get 12. So this is 12, and this is kilometers per liters. So kilometers per liter. Okay. Let's see, slope of B is going to be 270 over 30, which will give us 9 kilometers per liter. Okay? Part B, what do these gradients mean? So, again, here we've got this slope here. This means that if you're driving, let's see, the fuel consumption, so the distance traveled is, for this one, is 300. You're going to use 25 liters. So basically you're getting 12 kilometers per liter if you're doing, let's see, graph A. So at 60 kilometers per hour, you're getting better gas mileage than you are getting that if you are driving at 90 kilometers per hour. Okay, so this is basically how many kilometers you're going to get out of every liter. Okay. Part C, if fuel costs 94 cents per liter, how much more would it cost to travel 1,000 kilometers at 90 kilometers per hour compared with 60 kilometers per hour? Okay, so let's do this. Let's figure out how many liters we're going to need for each one to travel at 1,000 kilometers. Okay, so part C, we've got okay, sorry, we're trying to figure out the total liters that we're going to need. So if we're traveling 1,000 kilometers, if we divide that by 12, that gives us, divided by 12, gives us 83.3. So if we are traveling at 60 kilometers per hour, we're going to need 83.3 liters. Okay? If we're traveling 1,000 kilometers and we're only getting 9 kilometers per hour, kilometers per liter, that is going to, mean that we're going to need 111 liters to make it that far. Okay? So they're asking, says it costs 94 cents per liter. How much more would it cost to travel at 90 kilometers per hour than it would at 60 kilometers per hour? So we just got to figure out how much this is going to cost. So we're going to take our 83.3 and multiply that by 94, and we're also going to take our 111.1 and multiply that by 94, and we'll see what we get for each of those. All right, so let's see, 83.3 times 94 gives us $78.30. All right, and then if we do 111.1 times 0.94, that gives us $104.43. 43, is that right? Yep. Okay, so again, we're not actually done yet because they're asking how much more would it cost. So now we just got to take the 104.43 and subtract our 78.30 to see what our difference is. So take that, subtract 78.30, and we get $26.13 more. About, okay, because we rounded these off. So there we go. That is number 4. Okay, last one we've got is number 5. Okay, graph alongside indicates the taxi fare charged for distance traveled. Okay, what does the value at A indicate? Okay, so this here again is up to, so this point is actually 0, 2. So that means you're going to have to pay $2 to travel no kilometers, right? Which really means, what does the value at A indicate? That really means basically you have to pay $2 really basically just to get in the taxi, and then you start paying your paying for however many kilometers you travel. You have to pay a standard rate for that. Okay, so A is just the cost for just getting in the taxi basically. Okay, find the slopes of the line segments AB and BC. What do they indicate? So let's find AB. Right, so this is the slope of AB. We've got 14 minus 2 over 10 minus 0. So that gives us 12 tenths, which is 1.2. And again, that's going to be $1.2 per kilometer. Okay, so what do the gradients indicate? So it's $1.2 per kilometer for the first 10 kilometers. And then the slope of BC is going to be 24 minus 14 over 20 minus 10. So that gives us 10 divided by 10, which is 1. So that means that's $1 per kilometer. So that means after you've traveled 10 kilometers, they give you a little bit of a break. It's a little bit cheaper. Now it's only $1 per kilometer that you travel. Okay. Let's see. So that really was, sorry, that was part B. So part C, we've got if a straight line segment is drawn from A to C, find its slope, and what would this slope mean? So that's going to just be, so from AC, that's going to be 24 minus 2 over 20 minus 0. So that gives us 22 over 20. All right, so if we do 22 divided by 20, we get 1.1. So that means, on average, you're paying, after you pay your $2 just for getting in the cab, you're paying $1.10 per kilometer on average if you were to go 20 kilometers. All right? Okay, that is all for 7C. If you have any questions, please ask them in class. I'll be happy to help. Thanks.